Good afternoon, everybody, and happy Wednesday. Welcome to today's webinar where we're going to take a look at Windchill's MPM Link. We're going to see an overview and a demo. And as I wrote in the invitation email regarding this webinar, this gives the manufacturing department the ability to continue working and moving forward instead of waiting on other departments like engineering to fine tune their designs. They can still move forward with what they need to do. And Zach Carson from PTC's Virtual Center of Excellence is going to tell us more about that today. So if you have any questions type those into the chat box. We'll try to answer them as we go along. And let's get started. Zach, it is all yours.
All right, thanks, Rob. Well, today we're going to be talking about MPM Link, and it stands for Manufacturing Process Management. It's all about manufacturing, if you couldn't guess from the name. So the idea with this tool in Windchill is essentially to give you a bridge from design to manufacturing. What we see a lot of times is that there's a pretty big disconnect between manufacturing and engineering. I come from a manufacturing background. I've seen this firsthand, so I know how it works. And it's not just here and there. I mean, this is something that's very prevalent across the industry. It feels like with everybody that we talk to. So whenever we talk to these people, really the reasons that they need MPM Link and Windchill, they're all pretty similar. If you don't have MPM Link, you're going to deal with these kinds of challenges. So number one, the design process is slow and tedious. And then during the process, teams like manufacturing really become unproductive because they're waiting for designs and changes to be completed and released. I've seen this happen firsthand. Manufacturing is constantly getting put behind the 8 ball so many times just because the design process, the change process, it takes so long, especially if it's a pretty big change that you're making. And for them, they don't want to build in the meantime because they're going to have to redo it. So they end up just waiting and doing tedious tasks that aren't really value add tasks. So a lot of times, the reason for this, almost every time, is just simply because of the disconnect between those two departments. Manufacturing has no insight into the product. They end up spending a lot of time just finding out resources they need and gathering information and then learning the assembly. There was times that I saw people would have no idea of an update or a change when it was happening. So they might have already assembled, let's say 20 different units and then have to go back and redo all of them. So you can imagine whenever you think about that, the cost and rework, the downtime. This is stuff that we talk about how detrimental it is to companies all the time. And it really is something that's very prevalent. Building on that disconnect, there's inconsistent data management and translation between engineering, manufacturing, and other downstream users. And that just results in the downstream users using out-of-date BOMs, out-of-date drawings, and just, again, being generally unaware of the changes to designs and assemblies. And in the end, what this all ultimately results in is rework, is higher costs, and potentially delay in time to market. On the engineering side in particular, what we see a lot of times is there's an inability to reuse the manufacturing processes and resources. Sometimes that's because it's difficult and tedious to transfer everything to new projects or products. And sometimes it's just simply because engineers can't find data in the system. They don't have a system really that promotes reuse. And a lot of times that means you end up with 3, 4, 5, however many parts that are just copies of the same part, but they all have different part numbers. So your inventory can get really out of whack in your PLM system, and there's not real visibility into the product as it changes. Because of the poor data sharing, what essentially happens is everything's just becoming a one-off design. So you end up slowing down your design time, you end up slowing down your time to market as manufacturing is more or less starting behind the 8 ball by the time it actually reaches their team. And then ultimately, this miscommunication, the disconnect between teams means a big increase in manufacturing costs, slower time to market. And I've seen this one too. Hopefully you don't deal with this, but potentially dissatisfied customers. The solution that PTC has for these challenges is Windchill MPM Link. This allows you to create and manage all of your manufacturing specific data and processes in parallel to the design data. In doing so, you're giving manufacturing their bill of material, drawings, even work instructions, like you can see on this slide, that they're able to work with while the engineers are still completing and fine-tuning the designs. So what is this tool actually giving you to help you do this? Well, number one, you'll have a different bill of materials update in real time. So you can create in Windchill downstream BOMs for different teams, such as manufacturing, which we call an MBOM or a manufacturing BOM. And that way they can have information that is unique to that manufacturing bill of material on the MBOM. So you don't really have to clutter up the engineering BOM or the master BOM with information for manufacturing that engineering frankly doesn't really care about or need to see. You just put it on the MBOM. They're still associated. So what happens is then if any changes happen, you can push the updates from the EBOM to the MBOM and use that MBOM to create process plans, which we'll do today on the demonstration. You can see a little snippet of it here. And really what we're doing is we're taking all of the engineering information, we're tailoring it for manufacturing, and we're giving them all the information they need to do their job right the first time. So this is literally taking your engineering BOM, your images, your visualizations in Windchill, everything, and you're giving it to manufacturing in an easy to consume way so that their work instructions and the other information that they're referencing is directly being pulled in real time from the most up-to-date engineering information. So you don't have to worry about them building to obsolete drawings or using an out-of-date BOM. It's all going to be the most up-to-date stuff. With that being said, yeah, now that you have somewhat of an idea what MPM Link is, let's go into a demonstration and we can walk you through how to use it. For today, we are going to be working with a car assembly that we have, and specifically, we're going to be working with the front wheel that's part of that Pro car assembly. So with this, within the manufacturing process management tool in Windchill or MPM Link, what you can do is after you create your manufacturing bill of materials, you can have different filters for each one of those BOMs. So in reality, what would happen is your manufacturers would come in here, they would naturally be looking and automatically be looking at that manufacturing bill of material. And then what we can do is if I open this thing up, I'll just show you the end product here first. We want to take all that information, build out an MBOM, build out our work instructions. So we'll go through the process of building this today, but the first thing I really want to show you what this would look like when it's all said and done, so you have an idea what we're going to be working towards. This is an example of the work instructions that a manufacturer might be making use of in Windchill. So someone has already taken the engineering BOM, they've created a manufacturing BOM, they've grabbed snippets of the visualization that they think are applicable to the step. And this whole worksheet here, which you could print, you could view it from Windchill if you're manufacturing, this is including all of the steps, all of the BOM items, descriptions, quantities, everything that manufacturing would need. So even if this is their first time completing this assembly, they have all the information that they need at their fingertips. They have all the parts broken down into the steps in which they need those parts with the quantities of the parts that they'll need and even descriptions for sub-steps that make up that step, as well as a clear visual representation of where they're looking at the object, the points of interest, and potentially even showing with the newer versions of Windchill, you can even include animations here to show you how things are being put together. All right. So we're going to start from scratch today, and we are going to walk through pretty much how quick and easy it is to create work instructions like that. All right, so for this, we're going to start from scratch. I'm going to open up my crank assembly, and this is what we'll use as the original part that we're going to take and make our work instructions from. And if you go to actions, the first step that we need to do is we want to create our manufacturing bill of material. And the way that we're going to do it is we'll pop open the BOM transformer, and this is the tool that we'll use to grab our engineering BOM and make it into a manufacturing BOM. This process is pretty straightforward. Essentially, you can copy and paste really whatever you want from the upstream, your engineering BOM, down to your manufacturing BOM. You could use the same tool to do a service BOM or the other downstream BOMs, but for today, manufacturing. And all that I'm doing here is I'm saying I want to grab a couple of these parts and I just want to paste them in my MBOM. All right, you don't have to do it all. You can grab the parts that make sense. Maybe not all of them make sense. Maybe all of them do. Let's put them downstream. And we're maintaining the links. That's the important part. And what that means is as long as we're maintaining the links, whenever we copy and paste them downstream between these two BOMs, then what's happening is anytime that the engineers open up their BOM, which is the one on the left, it's their EBOM, and make changes to that, since these two BOMs are associated, those changes can automatically be pushed downstream to the MBOM. So you don't have to worry about the situation where manufacturing's working from outdated BOMs or drawings or anything. You can reconcile the changes automatically in Windchill. They're always going to be up to date for manufacturing, which is really important because I've seen this. Manufacturing, like I said, a lot of times doesn't even know when changes happen. It's not their fault. They're just not in the loop because there's a disconnect. So this is really addressing that problem front and center. On the downstream BOM for manufacturing, there's of course information that they need on their bill of material that engineers probably don't put on the EBOM. So when we think of things that could go on your MBOM, we're thinking of consumables kits and things like lubricant, anti-seize, Loctite, stuff like that. So what we can do on the MBOM is actually just let that stuff live there, not cluttering up the EBOM with it. We're just creating parts on my MBOM, and these are just like any other WT part in Windchill. Someone could search this up in Windchill and reuse it in other locations. It's just another WT part. And some of this stuff, we'll say the source is buy rather than manufacturer. So this is a consumable that we're purchasing, that lubricant. And as soon as we're done here, all we have to do is go ahead and check this in, and then my manufacturing BOM will be created. Okay. Now from the bottom, if you look through a different tabs, you're looking at the visualization. But the next step in this process is making our process plan. You don't see anything right now because the process plan doesn't exist yet. So we're going to go ahead and make one from scratch. As soon as I click to make one, same GUI that pops up all the time with really any new parts or documents or anything. So with the process plan, we'll just put in a name. Best practice is definitely to put in a description as well, even though I'm not doing it. And then let's go ahead and open this up. With my process plan, this process plan page in Windchill is going to give you tools for creating the process plan. The UI looks really similar to if you looked at any other Windchill object. There's just some different actions and capabilities that you have whenever you're creating these plans. The first step in us creating this plan is we have to insert the steps. Okay, for this procedure, how many steps do we want? You could change this later on if you think a step needs to be added or something. But for now, we're going to just start with 5, and then I'm going to go ahead and rename them to represent what we want done at a high level on each one of these steps. That looks pretty good. Press OK. And then those are now renamed in my structure. So anyone who looks at this process plan now has a better idea what goes into each one of the steps. The next step is actually going to be taking our engineering information and allocating it to these steps. So right now, those steps have nothing in them. They're just simply names. We want to actually use the tool that we call the tree picker in Windchill. And I'm going to take the crank assembly that we started with. And all I'm doing here is dragging and dropping the WT parts from that assembly to the step where I want them to live in my process plan. The really nice part about doing this in Windchill is if you notice that visualization on the left in the bottom, that's showing me at the start the full assembly. However, as I drag and drop things to my process plan, you'll notice they leave that visualization in the bottom left and move to the visualization on the right, which is showing me what I have currently in this process. It's a really nice feature because it's going to give you a visual representation of what you have dragged from your part to your process and a clear indication if you've left something behind or forgotten to drag something over. A big benefit of using this tool is it's not just limited to parts. This is really where manufacturing can get a huge benefit out of using this. We are giving them every ounce of information they need. So it's not just, hey, you need this connecting rod, which is part number 3581. They could do that on their own anyway, right? What we're doing is taking this a step further. We're linking it to the engineering information, and we're getting more granular with the information they give them too. So I can come in here and I can even start dragging and dropping workstations on my shop floor that they're going to be going to assemble this thing. I can start bringing in users to say who's going to complete this step. Maybe this is a full start to finish process from the assembly all the way to the inspection. So an assembler might do steps 1 through 4, but an inspector might do step 5. We can actually put all of that criteria here in the process plan. And you can even get deeper and you can say, put in tooling here. Okay, so as an assembler goes into step 1 to mount the crankshaft, they need these tools and this value torque wrench, let's say. So that way they're not hunting it around. They don't even have to go to a torque chart and maybe misread it or get a wrong value from it and then torque it to the wrong spec. This is going to tell them everything. Continuing to build out this process plan just to give the assemblers as much information as possible. We can even break down for each one of those steps a detailed description like you might see here. Just for the sake of time, it's going to be pretty short and simple, as well as the time breakdown for each one of these steps. One thing that I saw a lot in my time in manufacturing was that the assemblers didn't actually know how long a process was supposed to take them. So they weren't sure if they were ahead of time or ahead of schedule. They weren't sure if they were behind schedule. So what this can do, and maybe you just use this even for just engineering. You don't have to give this to manufacturing if you don't think that it makes sense. But what this is telling everybody is, hey, steps 2 and 3 should take approximately 5 minutes. Step 4 should take approximately 2 minutes. Well, now what you can do is you can determine, hey, maybe this process is taking way longer than expected. And the assembler could actually look at this and say, all right, yeah, it's step 3 that's the issue. Well, now you can relay that information back to engineering and you could figure out, why is it an issue? Was it something that we just underestimated how long this step was going to take? Is there other issues that the assemblers are dealing with that's making it take longer? So you could actually use this as a way of troubleshooting for process improvement. The last thing that we want to do here is go ahead and check in our descriptions and our assembly and everything. But now I want to take what we have in those steps and start to add in the visual component of this. For now, everything that we've we've brought in here is simply Windchill information. It's the WT parts, it's tools, it's users. Now we want to add in either the graphical representations of the objects um, so that the assemblers or inspectors have a model and a visualization to reference, or even bring in animations and show how to complete a certain step, or where, let's say, a part is supposed to be inserted in the orientation that it needs to be inserted in. So what we're doing here is just putting in, we're saying for each one of these steps, I want to have a representation. And then we're going to use Creo View to open up this model and grab the representation that we want. There is some best practices here. So what you'll see whenever we open up Creo View to do this and edit these representations is that you kind of have to be aware of the view. Like, you need to make sure you're zoomed in. You need to make sure that you have a very clear view of whatever it is that you intend to show. If not, it is going into a document. That document's either going to be viewed on a computer or printed out. So you just want to make it easy to see, easy to consume. Right. And the idea is what we're doing here is we can use Creo View and I can put measurements in here. I actually have like my full structure on the left. So I can grab components, drag them away, add comments in. Let's say for this first step to mount a flywheel, I want to grab this visualization with these parts moved away and then put in a couple leader lines with a note to give them an idea. Hey, this is the part you're working with. Here's what you're going to be doing. Pretty easy to read. That's the first one. So we'll just save that annotation set. I call it mount flywheel. That's one. And then the other one, we won't do all 5 of these for the sake of time. But the other one that we'll do here is the inspect crank assembly. And it's going to be the same idea. We're using Creo View and the tools that it provides to mark this thing up and give the end users a very good visual representation that's easily consumable and usable to give them a reference. What I've seen a lot of times is that people do is they just physically take pictures of the prototype, put those on work instructions, which you could still do that. You can add those into Windchill, of course, and just attach them. In this case, a lot of times this stuff I think is much clearer. The picture is much clearer. It's much easier to see. You can edit the pictures easier in here, and everything's going to be contained within one tool. Well, looks good. And those are the only 2 that we'll do for now. So at this point, we've really added everything into this. We've gone into the tree picker and then grabbed the parts from the crank assembly, dragged them to the appropriate steps. We've named the appropriate steps. We've created visualizations for a couple of the steps. So the last thing that we want to do is just actually open up each one of these steps that we want very detailed or formatted descriptions for and start to bring in that information. So this could be additional pictures. It could be rich text options, little videos or snippets. It could be formatted bullet points or checklists, or really however you want to do it. And then once that's done, that's all there is to it. We're ready to just generate our work instructions. So this is what we're working with. You could see, of course, I didn't do all the visualizations. So there's not a few of them on these. There's the one I didn't zoom in enough on that one, but you get the idea. So we're putting in the visual representations here. We're adding in comments. We're giving time breakdowns. We're saying who's going to be completing the steps, what the BOM parts or BOM items are that they need for that step, as well as including any associated information. If they're looking at this in Windchill, the other really nice part about it is it's all hyperlinked. So if they were to, for some reason, let's say have to go and look at one of the BOM items apart, they could click on it. They have to look at a document, or maybe we even link the spec sheet that I'm calling out in the comment here. Well, then they just click on the link and there's your spec sheet that they can access. All right. So that's really what I had planned to go through for this demonstration. I do have one more thing I'd like to share to summarize what this can do for you. Whenever we talk about Windchill MPM Link, what you are getting from this, the benefit that this is giving you is, number one, a single globally accessible PLM system to design, to plan production, and synchronize with other tools you're using to have all of your design and manufacturing information in a single place. You get concurrent design and manufacturing, bill of materials, and processes to avoid downtime, or avoid waiting on engineering and make sure manufacturing is always working with the most up-to-date information. And then lastly, it provides well-planned and repeatable processes. So that way your designers can reuse previous designs, they can use the engineering information and add their own information in for things like work instructions, so that the end users really do have everything that they need to get their job done right the first time and be more productive, and avoid working with out-of-date BOMs, out-of-date drawings, having a disconnect when it comes to changes and updates. You're really connecting, building a bridge between manufacturing and engineering, which are traditionally two very siloed departments. That's all that I had planned to go through for this demonstration of Windchill MPM Link.
Zach, as always, excellent presentation.
Thank
I'm
you.
gonna have this recording set up to our YouTube page, and I'll have the link sent out to everybody by tomorrow. If you have any questions, want to see any more detail on MPM Link or anything else, Windchill or even Creo, you can just respond to the emails that are sent as the invitation for our webinars. Obviously, they come directly to me, and I can get you some more details, some more information. Or you can contact us at info@3hti.com. So next week, we're going to take a look next Thursday at noon. We're going to have a webinar on Creo Simulate that may or may not pertain to everybody on the line, but I just like to put it out there. I'll have a link, registration link to that webinar next week to see how your engineering department can actually run some simulations up front in the design and engineering department before those designs go downstream. So Zach, once again, thank you very much. And thank you to our audience for being on today. Have a great day and thank you.